Okay, let's go ahead and take a peek at finding the appropriate sample size. So what we've got here is a community activist group in Austin, Texas, wanted a particular issue to be placed on the ballot of an upcoming election. To make it to the ballot, 20,000 valid signatures were needed. The group turned in their petition with 24,598 signatures. To pass the validity test, we divide these two numbers and got 81.3% of signatures must be valid. It is too time consuming to check all the signatures, so a random sample of signatures are checked. The individual checking the signatures needs to be 95% confident that the true proportion of valid signatures are estimated with at most a 2% margin of error. So basically, we're taking our sample and the proportion of valid signatures in that, and we're adding 2% this way, and we're subtracting 2%. So we want our interval to be within here. So how many people would I need to sample? So what we want to remember is that the margin of error is composed of two numbers, the z-score, or the critical value, the z number, and then we plug in p with a hat, because we don't usually know p. Now in this case, we also don't have p with a hat because we haven't sampled anything yet to have a p hat, like a sample proportion. So what we're going to do is use what's called a conservative estimate. So just assuming like 50-50, essentially. I don't have a sample that I've taken yet because I don't know my sample size. So we're just going to assume 50-50 shot of signatures being valid or not. So we're going to just plug in that conservative estimate. So we want our margin of error to be 2% either side. So in total, we're adding or subtracting 2%. So our margin of error is that. For a 95% interval, our z number is 1.96. And I'm going to just conservatively plug in 0.5 for the p-hats. And here's where it comes down to algebra. So this is what I would do. I would divide away the 1.96 from both sides. We want to get n by itself. And then once I have that number, so if I do 0.02 divided by 1.96, I'm going to get 0.01 equals 0.55, or 0.5 times 0.5 all over n. This is all under the square root, so I would square both sides. So that's going to give me 0.0001 equals 0.5. Instead of writing 0.5 times 0.5, I'm just going to go ahead and write what that is. 0.5 times 0.5 is 0.25 divided by n. If I want to get n all by itself, it's currently being divided, so I would multiply both sides by n. And then divide away this number. And that's going to give me my final answer. So what I want to make sure of, though, is when I divide this, I get a whole number answer, and sometimes you're going to get a decimal. In this case, I'm going to get 2,500 people that I need at a minimum for my sample. If you get a decimal for an answer, always round up, because if you round up, the variability of your sample goes down, meaning the standard deviation gets a little less, so your margin of error is going to get a little less, which is what we want. So always round up if you do have a decimal here. So then for the next question, in the activist group's previous petition, 85% of signatures were valid. So let's say they actually did this once, and they did have a sample result for how many signatures were valid. In that case, it was 85%. So this is saying we did do this once. Let's pretend. And in this case, we would have a p-hat that we already have that we want to compare it to. So using this value as our best guess from previous activist groups, find the sample size needed for the margin of error for at most 2 percentage points again, with 95% confidence. So for this one, sometimes you do have a previous sample that you're working with, or you've done this once before. So in this case, we would basically do the same algebra again, just we have two different numbers here now. Instead of 0.55, we have 0.85 times 0.15. So if I do all the same algebra, it's basically going to boil down to very similar things here, but 0.01 if I divide by 0.196 each time. And you can round as long as you round appropriately. So I'm just rounding this off again to 0.01. I'm going to do 0.85 times 0.15 in here, just so I have that number. I'm going to square both sides. So that's going to give me that number again. And then I'm going to multiply and then divide away the 0.01. I'm going to multiply by n and then divide away the 0.01 from each side. So 0.1275 divided by 0.00101. Which is going to give me a sample of 1,275 people. So with this particular, if I'm expecting the same amount of signatures to match the study that was done before, or the sample that was done before, then this is how many people I would need. So this is a much smaller sample than going 50-50. So we actually have some data to work with. So lastly, what if the company president demands 99% confidence instead of 95%? Would that require a smaller or larger sample size, assuming everything else remains the same? So what we want to think about is to be more confident in our responses, we obviously need more signatures. So if I want to collect data, I'm going to need a larger sample size in this case, assuming everything else remains the same here from the previous study. I'm going to need to collect more signatures in order to be more confident in what I'm reporting. So a 99% interval would be wider, but so there's a more possible range of numbers there, but technically to be more confident, we would need a larger sample size.